Alright, let's get started, shall we? What the hell? Thank you very much.
Rest of the power photo. Almost broke. Oh, fired. Oh my goodness, no battery. Shoot. What?
Good. You can do that.
Is it broke?
No. Lucky for you.
That sounded like fighting words there, man. Alright, so it looks like I got to try to get through chapter 6 and chapter 7. As I'm catching up here.
That's probably stupid. I'm just going to bring my gorilla pockets in.
Okay, so tonight, interesting. They left the mouse key, but no mouse. Darn. We're going to talk about firewall and security appliances, which is, we're going to discuss the ASA in particular. We will also go over lab number 2. Lab number 2 is assigned tonight. If you downloaded lab 2 previously, throw it away, wad it up. I uploaded a revised lab 2 tonight. I changed a couple of criterion. Actually, I took out a couple things and made it easier. Okay, and gave you some options on it. What?
We just spent like the last 3 hours in the lab working.
It's 90% the same. It's just the ACS portion I've changed slightly, so it'll be easier. That's all. So had you gotten AD integration done with ACS?
No.
Okay, then you're fine. Don't worry about it. Everything else is the same. So, 2 types of firewalls that you will come across out in the field. Hardware firewalls and software firewalls. Okay? Differences between them, hardware firewalls is only going to inspect, typically, layers 1 through 4. Okay? the MAC address layer, the IP addresses, TCP, UDP ports, IP header information. Not to say that some hardware firewalls can't do this. When you get into talking about appliances, this here is still done in software, even if it's on a hardware device. Okay? Hardware can be a bottleneck. An actual firewall appliance can be a bottleneck within a network. Whereas a software firewall, host-based firewall, will have a single system impact, or can have a single system impact. Defends the edge, defends the applications and data on a single device or server. Now the firewalls that we will use in this class or talk about in this class, open source, Cisco Security Agent, Linux IP tables, and the primary one, the 5510, the Cisco ASA software that we'll get to in GNS3. Okay, there are two traditional modes of firewalls. Okay, traditional routed and transparent, or what's commonly called a stealth firewall. Now, you use either firewall in different situations. Okay? Typically, at the edge, you're going to have a router. Typically. All right? That's going to connect to your ISP. This being your LAN switch, where everything, all your PCs, workstations, yada yada are. In transparent mode, okay. In transparent mode, what you would typically have is an internal gateway on your router that faces the outside. Okay. This firewall is not going to have two addresses, one for each interface. It's going to have one address for management and management only. If you want to make this even stealthier, you don't give it an address on the network it's defending. You give it an out-of-band address on a different network. Okay, so that typical clients don't reach it. This would be an admin station. If you set up an out-of-band management mechanism like that, really easy to defend, okay? Because this network would not be routable anywhere else in the architecture. You just have to worry about defending this station, or make it really, really locked down. Don't tie that station, make it a complete standalone station on a separate network. Then you can't reach that firewall. The firewall then becomes very locked down. Alright? You have to have physical access to the admin station. Okay? This address is nothing more than a management address. It is therefore out of band, or transparent, or stealthy. If I were to scan this network, and I had NAT going through here, and I scanned the subnet and I try to find the hosts, okay, how they translated, I would not see that firewall. I wouldn't even know it's there. Okay? So that's an advantage to that type of system. I can't attack what I can't see. All right? 2 caveats to doing it this way. I can't have contexts. Contexts are firewalls within firewalls, or making a virtual firewall within the system. Can't do it. No IP addressing. Therefore, it can't be done. And I cannot do VPN. I cannot make this a VPN appliance. Again, no IP address, no VPN appliance. Even if I were to put a management address on this box that was routable to the outside, if I have the firewall in transparent mode, VPN commands are not going to work on it. Okay, so that's transparent mode. That's the hard one to understand. Routed or traditional, terminate. On the firewall itself. Okay? I can have DMZs. I can have multiple DMZs. Okay? It is a routed and routing device. Therefore, I can do contexts. I can make it a VPN appliance. I can put intrusion prevention system on it that will report back, or I can have it report back to an intrusion prevention system. Okay? The only thing I lose is its stealthiness. Questions on the different types of modes? Okay. You're going to be working with traditional routed mode in this class.
What's an example of a transparent mode?
It's just a bridge. An example is it basically just sits there, it's a bump on the wire, it will do packet inspection, it will deny traffic or drop traffic against its ACLs or allow it through. It will do NAT, but nothing else. It doesn't do any routing, it doesn't do any VPNs. It does not do any contexts. It's, you know, a simple inspection machine. Okay. Okay. Stateful inspection. We talked about this last time around. I want to review it a little bit. Okay. New connections versus established connections. All right. Who here can, in their own words, tell me what an established connection is from last lecture? Go ahead.
Isn't it when two, let's say, workstations, once the connection is made, the, let's say, firewall or whatever, it doesn't recognize, it doesn't bother to check, it's just transmitting whatever information is already.
Yeah. Simple explanation, a completed three-way TCP handshake. Okay? A completed TCP handshake. All right, that's what an established connection is. Whether it's inbound or outbound, doesn't matter. Okay. Now, the ASA will do application layer inspection. All right, to where it can look at some layer 7 applications. All right, like mail, DNS records, FTP information. And if you look at page 150 and 151, there's a good flow chart on the order of operations of an ASA. I've already kind of covered that a little bit in previous classes. I'm going to skip over it. Now, contexts, which you need to be in What mode? Routed mode or transparent mode that you do context? Routed. Okay? It creates a partition within the ASA or a virtual box within the ASA. Okay? Some features are still not supported with context. If I do context, I still cannot do VPNs because of the way it's set up. I cannot do dynamic routing. Everything has to be statically routed. In essence, it's like making a firewall on a stick instead of, same context as a router on a stick. Okay? Misprint cannot be set up in transparent mode. Cannot be set up in transparent mode. That correction. We're not going to deal with context anyway, so you don't have to worry about it. All right. Next big thing that you need to understand about firewalls. Most firewall vendors set security levels on their interfaces. Okay? And this is really important to understand which direction established connections go in. Okay? Because traffic originating on one interface and traversing to another interface will be denied or allowed based on its security level. Alright. There's also one thing you have to do with all interfaces on a firewall, on an ASA, beyond giving them a security level, is you have to give them a name with the name if command. And certain names are going to be predisposed to certain security levels. For example, if I name this interface that faces the internet, the most common name, the best practice name to give it is outside. Consequently, the interface that faces your interior network or networks, where your workstations are, your internal servers are, your databases, the stuff that you got to protect the most, is called the inside interface. Now, when I do the name if command outside, and I hit enter, it's automatically going to set the security level of that interface to 0. Okay? It cannot be a negative number. Alright? That is the least trusted interface out there. Okay? Rightly so, because I don't want to trust anything from the internet. Period. I don't know what's out there. Okay? Consequently, when I name inside, if I do the name if inside command, it's going to give me an automatic security level of 100, which is the highest I can go. It defaults to those. It's just how it's programmed. Now, doesn't mean that I can't go back to the inside interface and redo the security level. I absolutely can. I absolutely can. So, if outside is set to 0 and inside is set to 100, when I do another, let's say I want to name this interface here DMZ, I have to manually put in the security level because that's not a recognized name. It's not a recognized name. Okay? This changes from code to code. Cisco has made changes on it a lot of times. Sometimes in some code, 7.0 and maybe early 8, it may set the security level automatically to 0. Okay? And later 8.4, it just leaves it blank. Okay? But typically, what is best to do is put it somewhere in the middle between 0 and 100. Okay? So I like to set my DMZ, at least my first DMZ, to 50. Smack dab in the middle. Smack dab in the middle. Why would I want to do that? Anybody know? Why would I want to set in the middle? Why?
So if you come from this side, you gotta go far.
Nope.
No.
Nope. Has nothing to do with direction or traffic. Anybody else? Why would I want to set it in the middle?
Because you have to set requirements of what you want and what you don't want.
No.
Because it's between the outside and the inside.
What?
Because it's in between the outside.
It is in between the outside and the inside, but I could set it to 25 and it would still be in between the outside and the inside. I could set it to 75 and still be in between.
So 50 for testing purposes?
Nope.
It's not like it.
No.
You want to?
Nope. What happens if I have to create another DMZ? Or other purposes? DMZ2. The assets that I put on this DMZ, are they more trusted or less trusted than the assets that I put on that DMZ? I don't know. It depends. This could happen tomorrow, next month, next year, 5 years. Depends on the business requirement driving that. So when I make nameinf DMZ2, and set its security level I can then have adequate space, enough space to put it anywhere in between.
Would you also set that to, like, let's say 25 or 75?
Yep, exactly. If I set it to 25, it's less trusted than this DMZ. If I set it to 75, it's more trusted than that DMZ.
Okay, so
Now, what does that mean? Let me get into that. We'll set it to 25. Okay? If I have a workstation here on the inside and I need to access something on the DMZ, on this DMZ, or the outside interface, by rule, I do not have to set any type of access list in either direction. Because this device is trusted, I have free access in any direction. As long as my NAT is set up and routing is set up and all that good stuff. Don't have to make a single access list. Consequently, if I have traffic coming from this DMZ, right? I can access the outside. Not a problem. We don't need an access list.